Okay, I'm back working on the second of the ASR33s, and we'll start as ever with the chassis. I'll get this cleaned up, check it for any damage, and then we'll move on to the printer. So I removed all the old foam. It's completely disintegrated as usual, and I've then cleaned up the chassis. It's come up nice and clean, no real problems, few minor dents. The rear lip was bent, so I've straightened that out, fitted new foam, and the rest is fine. The rubber mounts a bit hard, but still serviceable, so I'll leave those in place, and the rest of it seems fine. So next thing is we'll get the printer onto the bench, have a look at that, and see what we need to do to get it working. So this is the printer out of the ASR33. As I said in the previous video, this won't actually turn. I'm hoping it's just a combination of all the various parts needing cleaning and lubricating. We'll start off by getting the ribbon out of the way. So I'll need to replace the ribbon. It's completely dried up. I do have spare ribbons available, so that's not a big issue. I can easily get that changed. Got some cleaning up here to do. I'll need to replace this petrified rubber bumper. The head itself actually looks okay. I can't see any damage on that. And what I'm going to do before I start, as usual, is I'm going to take this away. I'm going to give it a really good clean. And the way I go about cleaning something like this, in this case, we can see that some work's already been done on this, or at least some screws have been loosened off, and I'm not quite sure what's been done. But the way I go about this is I will remove anything that could be damaged by cleaning. In this case, what I'm going to do to clean this, it's not too bad, but there's a lot of crud and dirt down in the inner workings of this. Certain things have been disconnected. So what I'm going to do is I'm going to take out the motor. I'm going to cover up the solenoid, and then I'm going to wash it. I'm going to use detergent, water, and then a low pressure air line to blow it all out. But anything that could be damaged by the water, like the motor, I will remove first. In fact, water shouldn't really damage the motor if it's not left in too long, but it takes a very long time to dry out, so I'll clean that separately. What I can then do is start looking at all the various shafts and bearings and whatever, and start to try and free them up. There is some major damage down in this section, which is a bit of a concern because this is a critical part of the machine. The selector bars don't move at all, they're frozen, so I'll need to do something with those. The big knob that normally goes on the platen is missing, so I'm making up a new one that's currently printing as we speak. And so the first thing, we'll get this cleaned, have a look at it once it's been cleaned up, and we'll go from there and see what else needs to be done. Okay, I've taken the motor out, and while I was removing this I noticed that there was some damage to the solenoid and its bracket. So I've taken the solenoid out. Normally I'd just put a small polythene bag around this during the cleaning process, but this had to come out anyway, so I've taken that out. It gives me proper access to be able to carry out the repairs I need to underneath it. And I can now get the motor out of the way, along with its say start solenoid. And what I can do now is take this over to the workshop, give it a really good clean, and then start looking to see which parts of it are bound up, hopefully free it up, re-lubricate it. And these normally aren't too bad. It's, as I say, just the bit that needs repairing that we're going to have to look more carefully at. And also the solenoid itself is damaged. Also notice the other end of this is this lever at the front, which I noticed is also damaged. It's bent, this arm's bent, and it doesn't stay on, so that will need repairing as well. But that's part of this mechanism, but again it doesn't move, so I suspect that this has been kind of forced down at some point, and because the rest of it was frozen, then it's damaged this plastic lever. I'll also clean up the distributor. This doesn't turn, it's obviously part of the rest of the mechanism, and that won't turn at the moment. It's not too bad, but there is some pitting on here, and the way I clean these, I'll leave them in if they're not too badly damaged. I'll take the brushes out. There's a couple of brushes in this at each end of this spring, so I'll take the brushes out. Once this will rotate, I'll take the brush carrier off, and then I'll clean this, all the contact surfaces. This is just this outer segmented section and the inner circular section, and I'll clean it with 7000 grit abrasive paper. So 7000 grit is extremely fine, but it's quite effective at cleaning up copper, and we'll see if we can get this thing to start moving. Okay, so as you can see, I've given this a really good clean. It's come up really well. Even the underside of the chassis is now completely clean, so it's looking good. And what I did with this is just give it a real good dousing with a mixture of water and a mild detergent. Rinse it off, and then I provisionally dried it using a compressed air line. Now, if you watch my videos, you know that I'm a big fan of cleaning equipment before I start to repair it. And before I cleaned this, it wouldn't move at all. It was locked up solid, and I really haven't done anything else to it. I've just brought it straight back in. You can see it's still dripping with water. It is mostly dry, but there's still water in certain nooks and crannies, and it does need a proper drying off, which I'll come to in a few minutes. But already, without me doing anything else to this, it's freed up the carriage. And also, whereas it wouldn't turn at all before, it's now free to turn. So I haven't done anything else, I haven't lubricated it, I've done nothing, it will turn. So that's one of the benefits of cleaning things. It does of course still need more cleaning, lubricating before I can try and run it, but already it now turns, whereas before it wouldn't rotate at all. So you could spend ages trying to figure out why it won't turn, but in this case just a good clean has got it freed up. So that's good. It means there's no severe damage. It won't do a full revolution. It gets so far, and then this binds up. We'll come to this in the next video. But the next thing I have to do with this is dry it off. And this is one of the issues that people often have. They'll quite rightly be afraid to get things wet, and I strongly advise not to put water on electrical devices unless you really are sure you know exactly what you're doing, and even then make sure you dry it off properly. Something like a transformer, if you get it wet, could take up to a month to dry out. Even if you put it into a fairly high temperature, it will take a very long time to dry. What I do is, if I have taken this route, there are various things you can do. You can soak it. If it's a small device, you can dip it into isopropyl alcohol. That will displace the water, and then the alcohol will dry off fairly quickly. Something like this is too big, and also I wouldn't feel confident dipping this into isopropyl alcohol. If you do have something like this and there's a rust on it, don't dunk it into something like Evaporust. That removes any oxide layers, including the black oxide that's protecting a lot of these components. It will strip it off, and when you first take it out, it'll look fantastic. The next morning it will be a mass of rust. So water's fine as long as you dry it off as quickly as possible. You can elevate the temperature, use a hot air gun, but again, with devices like this that are a mixture of large castings and small components, you're probably just going to overheat a small component or plastic or bush, and you'll probably damage it. What I do to dry something like this is I've got an old water jacket incubator, and I set it to around 40 degrees centigrade. And what I then do is, in the bottom, I put this entire thing inside the incubator, and it just gently heats it up to 40 degrees. That won't really do that much to dry it, but what I then do is, in the bottom of the cabinet, it's a sealed cabinet, it's airtight, I put a tray of saturated salt solution. And to dry something like this, I would use a solution of magnesium chloride. And you basically, this is like crystal form in the way I get it. And what I do is just dissolve some of this, usually about a quarter of one of these containers, in water, distilled water, to make a very thick paste. That's then spread out on the tray, and the way this stuff works is if you put it in a sealed container and you create what's known as a saturated solution, then any air that comes into contact with the solution, if the humidity is above a certain level, then the water in the air will be absorbed by the solution. If the air is below that level, then the solution will give out moisture. Now, something like magnesium chloride, if I heat this to 40 degrees, at 40 degrees this has an equilibrium humidity, relative humidity of about 32%, which is very dry. And what that will tend to do is bring the entire air mass within the chamber down to about 32%, and effectively what will happen then is all the moisture that's in something like this will very quickly evaporate into the atmosphere within the cabinet. Because it's so dry, the water just comes out into the atmosphere, and being at 40 degrees it's very happy to give up the moisture. And something like this in 24 hours will dry absolutely completely in an environment like that. So that's what I'm going to do with this now. I'm going to go and put it into the incubator, put the tray of magnesium chloride into the bottom, heat it up to 40 degrees. I'm going to leave it until tomorrow, and then this will be completely dry, and I can then start work on it and start carrying out any repairs, get it lubricated. But because it will be dried fairly quickly, there's no danger that this is going to go rusty. The environment within the cabinet will be effectively bone dry, and you can get salts that will go even lower, and I tend to use magnesium chloride because it seems to work very well. It does pull a lot of moisture out of the air. Incidentally, it's also a very good way to dry a mobile phone if you dropped it into water. Don't use cornflakes or something like that, or rice. Similar sort of principle, but magnesium chloride will work infinitely better. Okay, so that's it for this video. In the next video we'll look at the damage to this. We'll try and get this mechanism working, so this will do a full revolution. We'll try and get the carriage ratchet to work. It's not working at the moment, and also we'll make sure that all the bars are freed up. So these still don't move properly. The machine itself will turn, but the release for this isn't working, and that's partly because this is damaged. So we'll look at the entire thing. We'll then look at the motor, try and get that to spin up, see why it was disconnected. The wires to the start relay were disconnected, so it might be we've got a fault there as well. But next thing is I'll get this thing dried off, and in the next video we'll get on to starting the actual repairs.